Alright folks, let's do another example using the idea of congruent triangles to show things about geometric objects. So we have on the right here a kite. So a kite has two sets of sides that are congruent, but the sides are adjacent. So that's a kite. And we want to show that in this case, the diagonals of this kite are indeed perpendicular to each other. It looks like that's the case, but again, unless you're reasoning geometrically, kind of your eyes can play tricks on you, even if you draw the diagram totally correctly. So this is something we're going to need to prove. So let me make a copy of this anyway. So because I want to keep marking on it. So there's my copy. This one will just leave, no, I'll leave the first one, and this one I can mark on. So the first thing we need to ask is, well, what do we need to show? Well, we need to show that these lines here meet at a 90-degree angle. Remember, that's what two lines being perpendicular means. And just as a reminder, the symbol here means is perpendicular to. So what we want to show, and again I'm going to use red to what we're going to show, well, we want to show that these angles are indeed all 90 degrees. That's what we want to show. So how are we going to get there? Well, we don't have any information about angles yet, but if we can use the idea of congruent triangles to show that we can find some triangles in our diagram that are congruent, then we get some angle information, and from there we might be able to keep going. So I think it's a good idea for you to pause the video and see if you can notice any time we can use a congruent triangle axiom, if there is an opportunity for us to use a congruent triangle axiom over in this diagram. Let me remind you of the congruent triangle axioms. Remember from last video, they are side, 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 angle, side, angle, side, angle, and angle, angle, side. If we know those three things are congruent about two triangles, we know that the entire triangles are congruent. So pause the video now and see if you can notice a place where we can use these axioms. All right, well, hopefully you've seen that we have a left triangle here and a right triangle where we can use side, side, side. AB is congruent to BC, AD is congruent to DC, and BD is congruent to itself. Maybe I'll put some tick markings in here just to make it look a little better. So what we're going to get is we're going to get that via side, 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 that the triangle ABD and CBD, the triangles ABD and CBD are indeed congruent, which is great. So let's kind of write down what we're going to do. So our kind of skeleton is we're going to use side, side, side to show that triangle ABD is congruent to triangle CBD. And once we have that, we know the angles of those triangles are congruent. So I'm going to go back up. I'm going to make another copy of our diagram, make it a little bit bigger, and then mark up on that. So let's go here. Bring that down. And let's see if I can make it a little bit bigger. Oh yeah, no problem. Okay. So we know ABD and CBD are congruent, so let's put in some angle markings that state that. I'll use blue. So we get that angle ADB is congruent to angle CDB. We get angle CBD is congruent to angle ABD. And we get this BAD angle is congruent to angle BCD. Okay. So from here, we have a little more information. We're starting to talk about angles. Now we have to think about a good way of showing that these angles are congruent. Remember, that's our goal, is to show these angles here are all congruent. They're all 90 degrees. In fact, via the X rule, if we show one of them is 90 degrees, we get that they are all 90 degrees. So that is our next goal. Since we have these smaller triangles, just to help our naming, maybe it's a good idea to name this point in the middle here. Let's call this point S. So again, we're always looking for the case when we can use one of these axioms. So let's see if we can find another set of triangles that we think are congruent and what axiom we can use to show that. So again, maybe it's a good idea for you guys to pause the video here and see if you can reason out if there's an opportunity to use another one of these axioms. All right, so the one that I see is the following. In fact, there's a couple of ways of doing this. It doesn't really matter which one. I see this top left triangle and this top right triangle. I can be able to use side angle side. So I'll mark this in green, I guess. So, oh no, I'll mark it in blue again. So I have that BS is congruent to itself in the triangle CBS and ABS. Of course, that side where they both meet up. I have that AB is congruent to CB. And I have that this angle ABS is congruent to CBS. Since I have all of those things, I can use side angle side. So we're going to use side angle side to show that triangle ABS is congruent to triangle CBS. And we couldn't do that before because we didn't have any angle information. It's the fact that we noticed that the larger triangles on the left and right were congruent. We're able to get some angle information to help us out. But once we have that, what we get in particular is we get that all angles in our top left and top right triangle are congruent. I'll call corresponding angles. So in particular, we get that ASB, this angle here, is congruent to angle CSB. And that AS and C all lie on a straight line. So that must mean that ASB and CSB sum to 180 degrees, that they're supplementary. And then we have it. Then we have that the lines are perpendicular. So let's just quickly write that as a little note to ourselves. So in particular, we get that angle ASB is congruent to angle CSB. And since S is between A and C on the same line, then the above angles are supplementary. So, therefore, they are 90 degrees in measure. So, in some sense, we've done it. We've determined that our angles here are 90 degrees. That means that our lines are perpendicular. We just have to write it up in a nice proof to make sure that everybody can follow our reasoning. So that's our next step. Once you've kind of figured out the problem, this is like our, for those of you taking humanities courses, this is our first draft, or our little sketch pad. And now we have to write it up in a way that people reading it can understand our reasoning for sure. So we'll write it in a little more detail using this two-line proof. So, wrong color, I'll use black. So we have result, and the reason, we can say we have that result. So, the first two things that we have are, of course, let me make another copy of this triangle, or of this quadrilateral, and bring it down. So maybe I'll do that first. Maybe I'll do one of these ones up here. Let's do this one again. Just bring it all the way down, just so we have something to refer to. Okay, so the first one, well, we know that line segment AB is congruent to line segment CB, and we know that because it was told to us, it was given. The second one is we know that AD is congruent to CD, and again, we know that because it was given. And the third thing is that BD is obviously congruent to itself, and that is because of reflexivity. So there are three sides that are congruent, right? So I wrote down which corresponding sides are congruent. So you can see here, AB is congruent to CB, AD is congruent to CD, and BD is congruent to itself, BD, in our triangles, ABD and CBD. So I can use them now to get the triangles ABD and CBD are indeed congruent. And we know that by the side, side, side axiom. And I like to tell people how I reason that. That's by 1, 2, and 3. There are the three sides of each corresponding triangle. We have that they are congruent, so the triangles are congruent. And remember, the key thing is, once we know the triangles are congruent, we know all sides and all angles that are corresponding are congruent. Okay, so let's keep going. The next thing we had is the only angle we really cared about, and I'll just mark it in, the only angle we used was AB, well, we called it ABS. So, in particular, let's write it like this. So we know that angle ABD is congruent to angle CBD. That's what I just marked in red. And we know that by congruent, that looks more like a G. Congruent triangles, and that's from 4. I always like to note what previous lines I'm using to make my determinations. Okay, so I have those angles are congruent. And then, well, I also know that angle ABD is the same angle as ABS. And the reason I know that is because B, D, and S all lie on the same line. So it's because B, S, D, all of those guys are on the same line. You can kind of see that here, right? So here's a line BDS. It's one side of our angle. We just picked a different point on that line rather than point D. We picked point S, but that angle here is going to be the same. And it's the same deal with angle CBD being congruent to angle CBS. And it's because B, S, and D all lie on the same line with the points in that order. So now we're set up to use our side angle side axiom. Again, we're going to use the fact that ABS and CBS have two sides that are congruent and the included angle. So let's go ahead and tell people that that's what we're doing. So we already have that AB is congruent to CB. We don't need to write that again. And we have that angle. We need that angle ABS is congruent to angle CBS. And we know that, well, we know ABD and CBD are congruent, and ABD is the same as ABS, CBD is the same as CBS, so obviously ABS and CBS are congruent, and we know that by transitivity. And we're using lines 5, 6, and 7 for that. So when you're doing chains of congruences, that's when you're using transitivity. All right. So we have side angle. The other thing we need is the side. So that is that side BS is congruent to itself. And that's from the reflexive property. All right. That's great. So now, here is our first side, 1. Here is our angle, 8. Here is our second side, 9, 1, 8, 9. And on the other triangle, 1, 8, 9. We get that those little triangles are congruent. So triangle ABS is congruent to triangle CBS. And just a quick reminder, I'm being careful to make sure that the vertices I'm listing are in the corresponding order, else I'm using the notation incorrectly. And the reason I know this, we just talked about it, this was side, angle, side. And the axioms, the lines that I used to show that, well, the first side was 1, AB and CB are congruent. The angle was 8, that ABS and CBS are congruent. And the last one was 9, that BS, that shared side, BS, is of course congruent to itself. So when you do those we have those shared sides, you're most likely going to use the reflexive property in your proof there. Okay, so we have that those triangles are congruent. And the last thing we wanted to say was, well, we know those ones are congruent, so we get that in particular, angle ASB and CSB are congruent. So angle ASB and CSB are congruent, which is great. And we know that because of congruent triangles. And that's from 10. All right. So the last thing we need to say, or the last few things we need to say, are just indicating that these guys are indeed supplementary. So angle ASB, I don't want that symbol, is supplementary to angle CSB. And how do we know that? We know that because S is between A and C on the same line. Again, let's go up to our diagram and we can see that. So here's ASB, here's CSB, our angles here. AS and C all lie on the same line. So the angles with vertices S have to be supplementary. So we have two congruent supplementary angles. So that tells us that we know that 2 times the measure of angle ASB is 180 degrees. And that's by 11 and 12. So 12 tells us that the measure of ASB plus the measure of CSB is 180 degrees. They're supplementary. But line 11 tells us that the measures of ASB and CSB are equal. So since they're equal, I'm adding them together twice, so it's 2 measures of ASB. Or you could write it as 2 measures of CSB because they're equal. But anyway, that equals 180 degrees. So line 14 is that the measure of angle ASB is, of course, 90 degrees. We just divided both sides by 2. And so I guess the reason we could put here is algebra. Why not? And we would just manipulate it. Line 13. And then finally, well, we have that an angle is 90 degrees. So that tells us that BD is perpendicular to AC. So let me scroll up here and just kind of point to that. So we know that these angles are 90 degrees. So we get that the lines that make up the X have to be perpendicular, of course. And we know that that's the definition of 2 lines being perpendicular. They meet at a 90-degree angle. So this is the definition of perpendicular. And we made that reasoning from line 14, since we had one of those angles was 90 degrees. And that's what we wanted to show. So we're done, which is fantastic. Again, let me just quickly talk about what we did here. Well, in this part of our argument, we were doing those two left triangles, those two left and right triangles, the big ones, showing that those were congruent and that these corresponding angles were congruent. We used side, side, side for that. Here we were just saying that in 6, 7, and 8, we were just saying that angles ABD and ABS were the same, because S was just a point on the line BD. Of course, those angles are going to be the same. Down here in 10, using 1, 8, and 9, I guess in 9 as well, and 8. Let me erase that and make that a little bit prettier. So in 8, 9, and 10, we were showing that the top left and top right triangles were congruent via side, angle, side. And in particular, we got that these angles were congruent, and we just had to reason that those angles were indeed 90-degree angles. But this part of our argument here is basically saying that our angles lie on a straight line. So we have these guys are congruent. So they have to be, what do I want to say? They're congruent and they're supplementary, since this vertical line breaks up a straight line. Since they're supplementary, well, and they're congruent, they both have to be 90 degrees. And then, well, what does it mean when two lines meet at a 90-degree angle? It means they're perpendicular. So that's what was going on with this argument.